Now we're going to learn something called the quadratic formula. This formula can be used to solve any quadratic function, not just ones that we can factor. So you just heard my children sing the quadratic formula for you because I will not record myself singing. If you're really, really nice, I might sing it for you in class, but there are no guarantees. Starting off, we have quadratic functions in standard form. So we have y equals ax squared plus bx plus c. Remember, a, b, and c are all numbers. So to solve for x, we can substitute them into the quadratic formula. Remember when we factored, we usually got two binomials, and we would get two different answers when we solved for x. So in this formula, we start off with the opposite of b plus or minus. So that piece right here tells us that we can potentially get two answers. One would be the opposite of b plus the square root of b squared minus 4ac all over 2a. And our second answer would be the opposite of b minus the square root of b squared minus 4ac all over 2a. So let's take a look at how this works with numbers. Looking at our steps off to the right, the most important rule is number 1, your quadratic function must be equal to 0 in order to solve. We already saw that when we were solving with factoring. Same rule applies when we're solving with our quadratic formula as well. Step number 2 is check to see if it factors. If it does factor, it is easier to factor than solve instead of always using quadratic formula. Looking at number 1, does anything multiply to 3 that adds to -5? No, so we can go ahead and use quadratic formula. So x equals opposite of b, so our a is 1, b is -5, c is +3. The opposite of -5 is 5, plus or minus the square root of b squared. Even if b is negative, I drop that sign because once you square it, the value becomes positive anyway, and it's one less negative sign to keep track of. This formula is not real easy to use, so the easier you can make it for yourself, the better. Minus 4 times a times c, that's a 3, all over 2 times a. And then we simplify. So under the radical, we've got a square and we've got some multiplication. Because they're separated by a subtraction sign, we can do those at the same time. 5 squared is 25, and -4 times 1 times 3 is -12. All over 2 times 1. And then finally, we'll go ahead and subtract inside the parentheses. So we have 5 plus or minus the square root of 13 all over 2. The last thing you'll do is check that value under the radical. We did learn how to simplify radicals. We will be putting our answers in simplest radical form. 13 does not have a perfect square factor, so this one is simplified. As a reminder, our two answers are x equals 5 plus the square root of 13 all over 2, and x equals 5 minus the square root of 13 all over 2. We just like to simplify those two together by using the plus or minus sign. Our second example is not set equal to 0, so we're going to get that 4x over on the left-hand side by subtracting it. So we get x squared minus 4x plus 8 equals 0. Does it factor? Yes, we have a common factor. We can divide everything by that lead coefficient of -1 that's in front of our x squared right here. So dividing that -1 out, we get a positive x squared plus 4x minus 8 equals 0 divided by -1, but that's still 0. Then we can check to see if we can do our t-chart. Does anything multiply to -8 that adds to 4? Nope, that one doesn't factor either. So we're going to set up our quadratic formula. Identifying our a, b, and c. A is 1, b is +4, c is -8. Then we can substitute those values into our quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, don't lose the negative sign on that c value, all over 2 times a. Starting to simplify, again, we're going to work inside the square root. 4 squared is 16. Negative 4 times negative 8 is a positive 32. Again, be really careful with those negative signs. All over 2. Adding under the radical, we get 16 plus 32 is 48. And this one does simplify. I'm going to go off to the right here and just simplify the square root of 48 as a reminder of how we simplify radicals. 48 has a perfect square factor of 4. It does have a bigger perfect square factor. Some of you may not recognize it, but 4 is one that you probably do. 4 times 12. And then 12 has another perfect square factor of 4. So there's a couple of different ways that we looked at writing this. We could write the square root of 48 is equal to the square root of 4 times the square root of 4 times the square root of 3. Taking the square root of each of those 4's, we get 2 times 2. Make sure when you take a square root, you drop the square root symbol. The square root of 4 is regular 2. It is not equal to the square root of 2. So pull that 2 out from under the radical and then multiply your 2's together. So the square root of 48 simplifies to 4 times the square root of 3. So I'm going to substitute that value back into my quadratic formula. So I get 4 plus or minus 4 times the square root of 3 all over 2. And then we can butterfly with that 2 in the denominator, dividing it by the negative 4. So we get negative 2. And then dividing it by that one as well, we get 2 times the square root of 3. Don't lose your plus or minus sign. Our two answers would be x equals negative 2 plus 2 root 3 and x equals negative 2 minus 2 root 3. Example 3, similar to the last one, we have to get it equal to 0. So I'm going to add that 2 to both sides. In this case, we have a coefficient of 3 on our x squared term that I can't divide out of every term. This one might factor, but you don't know how to do that just yet. So we have to use quadratic formula to solve this one. Identifying our a as 3, b as 6, and c as 2, we're going to substitute this into the formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Simplifying under the radical, we're going to square 6, which gives us 36. 4 times 3 is 12, times 2 is 24. All over 2 times 3 is 6. Subtracting 24 from 36 gives us 12. And we can simplify 12 as well. We did see that on the last one, but as a reminder, the perfect square factor of 12 is 4. So the square root of 12 is equal to the square root of 4 times the square root of 3. Taking the square root of 4 and dropping the square root symbol when I take the square root, we get the square root of 12 is equal to 2 times the square root of 3. So I'm going to substitute that back into my quadratic formula. And I can butterfly this one, but it just simplifies. So what I'm going to do is, instead of dividing by 6, I'm going to divide everything by 2 to simplify. Another way to think about that is looking at our numerator. 6 and 2 both have a common factor of 2. So I can pull out a 2, leaving me with negative 3 plus or minus the square root of 3. And then I can just kind of simplify that 2 over 6. 2 over 6 simplifies to 1 over 3. So I can drop the 1 because multiplying by 1 doesn't change anything. So I get negative 3 plus or minus the square root of 3 all over 3. You have one U-try question. Get it simplified as much as you can. If that was a tricky part for you, we can work on that in class.